coming to you from Jezero crater on the surface of Mars. This is Mr. C.
Monday already, and I'm going to start off by showing you this. By the way, good news as usual. Good news. So I'm going to take you out to a couple of amusement parks at the end of the period, and you're going to have to ride a roller coaster. So, in fact, I'm going to try to do a roller coaster a day, and I'll get to that in a little bit. Okay, check this out, May, huh? So, and a belated month of the month to you. So, on Saturday, right? So, here we are, May 2nd. Already, if I got this right. So, yeah, there it is, May 2nd already. And check this out. It'll be hard to see a little bit, but there is this week, kind of a normal week. This week, kind of a normal week. This week where I have triple R all over it. See that? So we're going to review and cover a bit more geology, a little bit, but I'll be reviewing. Actually, I'm going to be reviewing a little bit each day this week and next week. It's the way I do things. Lots of review. I want you to know way ahead what's to be expected. And then this week right here, the week of the 24th, 24, 25, and then 26. Those are your semester exams. Okay? So anyway, I wanted you to know all of that. First, a little bit of change. I ended up talking to Mrs. C, and she recommended, here's what she recommended. She recommended that I change and not give you today any study guides because it's still 3 weeks away from finals. 24th, right? So 3 weeks away. So I'm taping on Sunday, so it's the 3rd on Monday, and then 3 weeks is the 24th. So you'll have your, I think, your first and second period test on Monday the 24th of May. So anyway, her recommendation was wait till next Monday, get out study guides, and then the following Monday, study guides out. So next week, Monday, I'm going to get out a general packet that has general topics on it. And then also quarter number 3 tests with answers. And then the following week, which will be a whole lot like the 17th, that Monday, I'm going to hand out quarter 4 tests. So anyway, good news, right? Further good news, no test this week, one more test a week from Friday. I decided I'm not going to do a test this week, too much to do. So now if it's all right with you. Now if a bunch of you get on chat on Teams, and say 50 of you chat me and go, oh please give us a test. Okay, I might consider it, but probably not. So anyway, you probably don't mind. Okay, look what I've got going here. See this? Semester exam topics for 7th grade. So here are topics I've already written down. You just take it to the bank. Guaranteed. This is going to be on your final. So this information. See the first thing? SSRs. What's their purpose? To enjoy. To enjoy. So the purpose of an SSR? Its purpose? To enjoy. That's why God gives them to us. And then our response to thank Him. So anyway, on the final, I'm going to ask you several questions about, or at least one about SSRs. Now, what kind of student would probably go, wait a minute, I'm going to start in my journal a semester exam section. Every time Mr. C says, that's on the semester exam, I'm going to stick the topic in there really quick. You know what kind of student would do that? A good one. Yeah? A good one. A wise one. A wise student. Anyway, SSRs to enjoy. Gardener's Smarts. And then the Go Tappy package. Do I have that? Yep. All of this is going to be there. Gardener's Smarts. Word Smart. Art Smart. Music Smart. People Smart. Self Smart. Math Smart. Nature Smart. God Smart. Body Smart. We're not all, naturally great in all those areas. It's part of our Go Tappy package. Gifts, opportunities, talents, abilities, physical appearance, purpose, and one more, and then made in God's image. The other P will pop in my head. And then all of that makes up your super power. You. And then check this out. Your superpower, who God made you to be. Laura's going to give you a study guide where she's got 6 to 8 things that she wants you to remember. I'll ask you for a few of those on the final. Which ones? I'm not telling. So you will get next Monday her little study guide. And then next, scientific method. We're going to use the scientific method in connection with roller coasters. So scientific method. So you remember, and here's the way it's going to go with the roller coasters. So which roller coaster is the fastest? That's the problem. Then you all will probably have a hypothesis. I'm not a coaster person. If you put me on a roller coaster right away, you discover it's the Diet Coke. You put me on a roller coaster and right away you discover my stomach contents. And you didn't want to. And I didn't want to reveal my stomach contents. So that's why I don't go on roller coasters, and you're glad that I don't go on one with you in the same car because you don't want me spewing all over you. I get it. Yeah, I get it. So some of you are designed to ride on roller coasters, and you're a thrill seeker, and there's not much fear there. What you've got to learn is to be careful, to not, be too dangerous, and get injured. So anyway, my number one daughter is a thrill seeker. Love the big coasters, love to skydive. I don't get it. Okay, so anyway, let's keep going. Then you've got all your variables controlled. And then the one variable not controlled, the independent variable, that'll be the different coasters. And then the data will be how high they are and how fast they go. So what's the drop from them and how fast are they? We'll do a couple of those today. Couple. How cool is that? So I'm going to put you on a couple of roller coasters. So then I'm going to ask you about, I'm going to ask you scientific method, of course, then you get a conclusion. Then I'll ask you questions about proteins, made of amino acids, 1 over 10 to the 164th, that a modest one could form accidentally. No way. There's no way that's happening. Anyway, I hope that was relatively painless. We just reviewed a little bit for the semester exam. All those topics are going to be there. And you'll see all of that next Monday on the General Study Guide. So now I wanted to spend a little bit of time on the tests that you took last Friday. I've graded them all. Mr. C, I didn't see my grade in the computer. I looked, I didn't see it. Well, there'd be 2 reasons why yours isn't there. One, I have a folder of a few that I need to grade yet. And then I have given Mr. Phillip, I don't know how many, a handful out of each class to redo. Why? to redo. Here, I'll tell you why. I'll demonstrate it this way. This test right here, this person had a really nice note card. Filled it out really nice, or, paper, and got an A. So got an A, and their test score is in the computer. So their test is there. Now this person, I will not reveal the name, this person did not do a note card. And let's see. Oh, I know what I was going to say. I don't have one of those tests, but I had people who didn't use a note card and they missed 30 out of, or 25 out of 50, or 20 out of 50, or 18 out of 50. No note card. Those people are redoing. So you have to, Mr. Phillips is going to hand you out something. So if you got a redo, and the reason you would have a redo is no note card. So you were supposed to fill out a note card, and you've got to fill a note card out completely for this test. And in fact, I give you a test with all the answers. You've got to transfer the information onto the note card, and then you can't use that test that's filled out for your redo. You've got to use your note card. So you'll turn back in the filled out test to Mr. Phillip, and then he will give you the redo test. So you've got to make arrangements to do that in advisory. I told you it'd be a pain if you didn't use a note card. I said it'll be a pain. You'll have to redo. It'll be a pain. So what can I say? I gave you a heads up. So anyway, get it done on the redo. I don't want to have to come after you. So get her done. So now this test right here, no note card. And this person is in an unusual category. Able to take the test without a note card and get a perfect. Perfect score, no note card. Okay. One of their superpowers is probably a really good memory. So, super memory. Anyway, it was okay if you didn't use a note card as long as you got a good score. But if you didn't use a note card and you got a bad score, a low score, then you're in the redo category. Okay, so fill out your note card really well, both sides. Use the test information with the answers. Okay? So anyway, what else? Let's see. The science activities in the back. Okay? You, this week, along with Mr. Phillip helping, you need to check to see if you've got all those done. How many are there? A, 1 through 4, B, 1 through 4, C, 1 through 4, D, 1 through 4. 4 times 4. Multiplication, facts, 16. So you've got to have all of those done and done well. Nice job on those. Not just guessing, but actually reading and come up with the answer. Now, if you didn't do a great job, you'll want to get those done because you're going to turn that in to me. You're going to turn your journal in on the 19th of May. So in what are we looking at? 16 days. 2 weeks and change. So you're going to be turning that in. And it's not an option. And it's going to be a grade. Probably 32 points. 2 points each. So a big fat grade. So you want to do a nice job on that. So if you need to catch up, there might be a few days where Mr. Phillip allows some time at the end of the period. You can come in during advisory and work on all of that. So those science activities. So you've got 2.5 weeks. Get them all cleaned up, all finished up. So get with it. Hey, I wanted to show you something really quick. I've got my calculator. I wanted to show you why on the moment magnitude scale, then I'll go over the test, why on the moment magnitude scale that it adds up real quick. All right, what's the difference between a 1 and a 2 earthquake on the moment magnitude? Answer, 33 times. What's the difference between a 1 and a 3? The 3 earthquake is 1,089 times more energy-wise. Over 1,000 times more energy. Wow. Just a 1 and a 3. How about a 1 and a 4? A 4 earthquake is 35,000, almost 36,000 times more energetic than a 1. A 4. How about a 5? A 5 is 1,185,921 times more powerful energy-wise than a 1. That's a 5. How about a 6? I don't think I can get it on. Yeah, I can. A 6 is 39,135,393 times more powerful than a 1. That's a 6. And that's just a medium large. Medium large. I can't even get how much the difference between a 1 and a 7 and a 1 and an 8. Can you imagine a 1 and a 9? It's just, oh, I see now how fast they go up energy-wise, and how just one number is way more larger energy release amount. Yeah, amazing, huh? So I wanted you to see that. Okay. See how we doing. I wanted to show you this. I want to take you out to the Ring of Fire USGS website. Hey, I showed you before. You show your parents this? And I think I said 10 points, get a parent signature. I showed my parents the USGS website. I showed them the plate boundaries. I showed them the Ring of Fire, all of that. It's coming. Here it comes. And voila, there it is. Okay. All right. Check that out, Ring of Fire. There were some earthquakes just 20 minutes ago that were red, so they've gone to 2 hours ago now. But anyway, Ring of Fire and Mid-Atlantic Ridge. The big red lines are plate boundaries. It's where two plates come in contact with each other, and they're moving. Okay, and we'll go over the test in a minute and show you how they're moving. So Ring of Fire, is there one that just happened? Nope. But anyway, where do the big earthquakes occur? On the plate boundaries. Why don't we have big earthquakes in Arizona? We're not on a plate boundary. We're not between two plates. A plate boundary. That's why. Why are there always earthquakes out on the big island of Hawaii under Kilauea volcano? Because the magma's always moving. That's why. Magma moves, you get an earthquake. So anyway, and we're going to do, starting homework tonight, work on volcanoes. Okay, got to go over the test really quick. Here we go. So I'll use this perfect. Way to go, Anja Voigt. Okay, the verse, of course, the heavens declare the glory of God, the sky above proclaims the work of his hands. All creation shows off God's glory. Glory means greatness. So it honors him. Evolutionists don't like to say that. They try to cover it up. Can't. Just everywhere. Divine designs. Okay, a supermoon is a full moon that actually gets bigger, or it actually looks bigger. It just looks bigger. Why? Because it's closer to the Earth because of the elliptical orbit. That was number 5. Number 6. Name 2 things you can do to carry out God's command to take care of the Earth. Well, conserve water and don't pollute in any way. Don't pollute oceans. Don't pollute the air. Clean up. Just clean up in your own world. Clean up trash in your neighborhood with your parents' permission. What does the Hebrew word in Genesis mean that Adam and Eve were supposed to do to take care of the earth? It means to conserve. It means to save, protect, all of those things. Number 8, what's the big deal about proteins? Well, they do everything in your body, all the jobs, all the functions in your body. What are the 20 building blocks of proteins? AA's, amino acids. Why would it be impossible for a protein chain, a modest protein chain of 150 amino acids, to ever be able to form by chance? Because the probability is 1 over 10 to the 164th. That was a bonus of 1 point if you had the exponent, 164. One chance out of over 1 with 164 zeros behind it. What's the number one? Just impossible. No way, ever. It ain't happening in millions of lifetimes. Just can't happen. The number one job of the helicopter Ingenuity, not to crash. Keep flying. And second job, take pictures. Take pictures. Okay. All right, backside, here we go. Here are the minerals. Makes up most of the ocean crust, basalt, on the bottom of the ocean. Are these going to be on the final? Yep. These 15. Arizona mineral, lots of sand grains cemented together. Sandstone, of course. Sand grains cemented together, sandstone, logical, yeah. Mud rock, shale, gets squeezed into rock. Makes up much of the continental crust, granite, big chunks of granite on campus. Volcanic mineral, lots of holes, floats in water, pumice. Purple quartz, amethyst. Ordinary quartz, gave it away. It's black, very hard, volcanic glass. It'll scratch the streak plate. Obsidian. Lots of iron in it. It's rusty, very dense. I didn't put attracted to a magnet, but it is. Magnetite. It's coal, formed under every continent by the Great Global Flood. Anthracite. The mud rock, when it gets heated and squeezed and turned into slate. The writing mineral, graphite, pencil lead. Fool's gold, iron pyrite. Arizona mineral, lots of copper in it. Chrysocolla. I should have gone chrysocolla with a C, lots of copper. Chrysocolla with a C, lots of copper. Why didn't I do that? I don't know. I should have. 27, change from one kind of rock to another and give an example. Metamorphic, slate would be a great example, marble. Volcanic, igneous. These are on the final, guaranteed. And an example. Igneous, obsidian, pumice, granite, quartz, amethyst. Layers of dirt squeezed together. Sedimentary. Sandstone, shale, limestone. Minerals have 5 characteristics: naturally occurring, inorganic, they're solids, and the 2 C's, unique chemicals and unique crystals. On the final, guaranteed. Guaranteed. Just really important. Extra large ocean wave, usually caused by an under ocean earthquake. A tsunami, Tsunami. And then the specific location on the Earth's surface, on the surface, epicenter. Epicenter underneath is focus with a U. It's got a U in it. F-O-C-U-S, focus with a U, underground. Okay, hurry, Mr. C, hurry. Got to do homework. We got to do the coasters. 33, a large deep crack on the Earth's crust is a fault. An instrument used to record earthquake waves, a seismograph. These were all, every one of these were in the word bank, the matching. The scale from 1 to 10, moment magnitude. The specific location where rock breaks, underground, focus, I just did it. Vibrations that travel through the Earth's crust and shake things on the surface, seismic waves. Huge chunks of the Earth's crust that are slowly moving around, tectonic plates. Tectonic plates. Boy, a lot of this is going to be on the final. Explain, let's see, 2 ways buildings in earthquake zones are made earthquake safe. They have pads between the foundation and them. They're on rollers. They have shock absorbers. They have straps that go across like this and tie them together. Tie the ceiling to the walls, the floor to the walls. So anyway, there's like 5. Explain how the slowly moving big chunks of the Earth's crust can cause big earthquakes. Here's how. They lock up and they keep moving and bending the rock, like I did with the metric system ruler or meter stick. Here we go. So they keep moving and bend the rock and bend the rock, and then they break free. Might break free in a day, might break free in a week. Little earthquakes might break free in a year. Bigger earthquake might store up energy for tens of years and break. Big energy release. Okay, hundreds of years, massive energy release, biggest earthquake. Excuse me. Okay. Two of the three kinds of earthquake waves. Well, P for primary, S for secondary, and then the surface waves, right? P, S, and surface. Why Arizona only has small earthquakes? We are not on a plate boundary. We're not on the edge of two plates. We're out on a plate. So we're in a stable section of the North American plate. It's stable. So we're not near a plate boundary, several hundred miles away to the San Andreas Fault, which is the plate boundary between the Pacific plate under the Pacific Ocean and the North American plate that we're on. So there's your reason. Where the biggest earthquakes happen, 6 to 9s, they happen where an ocean plate contacts a coastal or a land plate around the Ring of Fire at the mid-ocean ridge. Those are all okay. All right, you were supposed to make 3 diagrams of the different kinds of plate movement. There was a 4th, and some of you gave it to me. I gave you bonus. And if you named them, I gave you a bonus. They're sideways, that's translation. Arrows going past each other, one that way, one that way. Okay? Converge, arrows toward each other. Diverge, arrows apart, like seafloor spreading. And then there's a kind of convergence where one plate meets another plate, an ocean plate meets a land plate and dives down underneath. Like in Japan or Chile, where the really big ones happen. Okay, one word synonym for the word quake, shake. Shake. That's what seismos means, or seismology, the study of shaking. What's the name of the earthquake zone where the mega earthquakes happen? Subduction zone. I gave credit for some other things. One example, I just gave you Japan, Chile, Ring of Fire. There are others. Okay? So anyway, there you have it, the test. And your homework, here's what you're going to do on your homework, and perhaps Mr. Philip would stick it up on the board. You have to read page 135 to 137. So read page 135 to 137. You're about ready to go on 2-minute coaster rides. And compare them. So page 135 to 137. And then on your own sheet of paper that you're going to hand in tomorrow, where do volcanoes happen? Where do they mostly happen? Say why, explain why, an explanation, and give an example. So, and there's several different ways that volcanoes form. So where do they happen? Why do they happen like that there? And then give an example. Okay? Where, explanation, explain why, and then example. Okay? All right. A couple of roller coasters. One of them is Wild Thing in Minnesota, and the other one is, let's see, can I remember it? Where is it? Did I write it down? It is, I think I did. Let's see, where is it? Oh, come on, Mr. C. I'm doing it from memory. I think it's, King something. Okay? the King Gada, maybe in New Jersey. Does that sound right? Anyway, have a ride on them. Okay? Hold on to your seatbelt and, take a barf bag with you if you need to. Okay? And then Mr. Phillip.